So I suppose we should get started here. Hello, I am Nick, and have you ever wanted to make your code do stuff that looks good? Well, boy, do I have the solution for you. It's GUIs. What is a GUI, you may ask? It's a graphical user interface, and then the S is just there to make it plural. Now I like to classify GUIs into 3 different types, and these aren't like official names, I just came up with them. You've got your text GUIs, which are just like for console applications. It's basically just making the console output prettier. Then you've got your component-based GUIs, which is, I didn't include this in the presentation, but C#, all the built-in stuff with that, that's what I would consider to be a component-based GUI. Basically anything where you've got like, this is a button, you put a button here, and yeah, stuff like that. And then you've got your renderers and game engines, and that's stuff where it's like, here is the math to make a square, and now rotate it 90 degrees constantly. And they've all got their positives and negatives. Text GUIs may not be as flashy, but they're usually a lot easier to work with. The renderers can do quite a bit more than the other two, but they're quite a bit harder to work with. And then the component-based ones are usually relatively in the middle. So I'm gonna be just running down a few different frameworks and engines and stuff about different options for GUIing. First one is ncurses. It's a library for Linux that's it's a text-based one. It lets you print stuff on the screen and keep it there while you print more stuff. Also does colors and underlines and stuff like that. Then you've got Love, which is technically a game engine, but it's also just like a graphics framework that also includes keyboard input and sound output, stuff like that. It runs on Lua, or you code it in Lua with it. Then there's Qt, which is it's a fairly professional one. If you are professional, then it costs a lot of money, but if you're open sourcing it, then it costs no money, which is pretty good. And this one's like, you can do a lot of stuff with it. It's not a renderer, but you can hook up renderers to it essentially and put those in a window within Qt. I haven't really done anything with it, but it seems like you can do a lot. SDL, that's a renderer with also, I believe, the keyboard input type stuff included. And it's basically an abstraction of OpenGL, where it takes all that stuff and makes it a bit easier to work with. And it's been used to make a lot of games, but you can also do non-game things with it. Then you've got Unity, which is just a straight up game engine, but it makes it easy to use because they've spent a lot of time making it easier to use. And it can be used for 2D, 3D. If you want to make something in 3D quickly, I'd recommend Unity, because you can just drag and drop cubes and stuff, and then code in C#. Then you've got your OpenGL and WebGL and Vulkan and OpenGL ES and Metal for the Mac operating systems. And these are like the most bare bones you can get for graphics frameworks. You're doing the individual draw calls to do linear algebra, but it's not actually like that hard to work with. You don't actually have to know linear algebra because it does it for you. You just have to know when to do the different linear algebra things, and I'll get into that later. Oops. Okay, so first off, we've got n-curses, and this will be the most familiar to you if you've just done the CSC 150, 250 type stuff, because you just do a sudo apt install ncurses-dev, and then you can use it as a C library. On the presentation, which is available at dsuprog.club, I've added a link to a guide for ncurses, which I think is pretty useful. But I also set up a quick example over here. It's only for Linux, so I need to use a VM. So I've previously did the sudo apt install ncurses-dev. And then if I just open this example file I made, I just made the most basic thing I could think of so you can see the very basics of the thing. So you always start with init scr, which just initializes the screen, and that just tells it, hey, I'm going to start doing the ncurses stuff now. Then this line here makes it so that when you type a character, it doesn't show it unless you tell it to show that character. And then with ncurses, you have a cursor, which is the same as this cursor on the screen here. It's that same type of thing. Where, let's see. Now I gotta keep my mouse over here. There. This box that moves around, it's the same as that. And to move that, you use wmove, and then you specify which window you're in, and you can make different windows that they can't overlap, and they're not like actual windows on the screen. They're still within the terminal. It's just little boxes that you can work within to separate out your different areas. But the basic one is std scr, and that's always there, and that's just the whole screen basically. So I'm gonna move it 3 over and 2 down, I believe. So then we get a text input, a single character with get ch, and that just waits until you input a character and then puts it into the variable. And then wad ch, that's basically just your print function for ncurses, but for a single character. And so once again you specify the window, then you specify the character, and then you've also got these options here, and there's a bunch of them in the list over here. Yeah, here's all the ones you can do here. It's basically just text effects. So with this one, it'll underline it, it'll blink, and it'll be gray. And then anytime you change the screen, you have to tell it that you've changed the screen and you need to update it with wrefresh and then the window. And then once it gets to the end, it'll close out automatically. So I put in an extra get ch here to have it wait until I press a character so that you can actually see the result. And then to make sure that the terminal stays normal after you've closed the ncurses program, you got to do the end win function. So if I compile this here, there. The only extra thing that you need to know for compiling with ncurses is you need to do the -l ncurses. So if I compile and run this, you can see that my screen's not the way it normally is. And now if I type an I, there's an I. It's not blinking though. I think that this terminal here doesn't have full support for all the things that ncurses does, but it is gray, so that's good. And if I type another character, then everything goes back to normal. So anybody have any questions about ncurses? You can type them in the questions thingy in the on the website, or you can say them in the Discord. So let's continue on to Love, also known as Love 2D. As I said earlier, it's basically a 2D game engine. I've used it to make a few games before, so I can show you one of those here. This is just in VS Code. I've made a project, but I should probably also say how to download it. It's here at Love 2D. You've got the installer here. You just download it and install it, and then to run a program, you just need a folder. So like, you make the project folder, and then it's you can drag that onto the icon for Love, and that'll run it. Or you can, in VS Code, set up some extensions. There's an extension for Love, and then if you've got that, then you can just press Alt-L, and that'll run the game from there. Otherwise, you can compile it into an executable. Love runs on all the main operating systems, as well as mobile, I believe. And you can also run Love on the web and the 3DS as well. There's a homebrew application that lets you run Love applications on the 3DS, so that's kind of cool. So if we go through the main sections of this program real quick, I won't go through the entire thing obviously because it's pretty long. Here I've got all the initialization stuff, and this just runs right at the start when the program opens. Then Love has built-in functions for different things that you just define those functions, and then those will happen in the situation that Love defines them to happen. So here we've got the update function that runs every frame. We've got the text input function. This happens whenever you input text, key pressed. The draw function, it's like the update function, but this is where you do all your draw calls and stuff. And it's all just like love.graphics.blank, depending on what you want to do. You can have it do stuff on when the screen is resized. I think that's the end of those functions. Yeah. And then you've also got a config file where you specify all of like the window height and stuff, and the title, and where you keep the icon that'll show up in the corner of the screen, as well as a couple of other configuration things like which modules you aren't using and whether or not you want it to be full screen. So yeah, I've included in the presentation a link to a pretty good tutorial for Love called How to Love. It's all of this. Goes through step by step, tells you all the things you need to know. It's pretty easy framework to work with. I'd recommend it if you want to make something in 2D. But you do have to use Lua. You can also use C or C++ for individual functions. It takes a little bit of finagling to get that to work, but the main stuff is all in Lua, and you can use C++ if you need the extra speed. So Qt, this is that like professional looking one. Like, I don't even know what all this is. You can have it run on TVs. But you use it with, they've got an IDE called Qt Creator, and that's how you make stuff with Qt. And the way you download it is you go to the website qt.io and then over to download try. And if you don't scroll down far enough, you might think that you can't just get it straight out for free. But down here you can see open source users can get it for free as long as you follow their specific guidelines when distributing the end product. And they've got all those listed here. So you can download and install that, and I've got it installed, and I'll just bring it up real quick. I don't have an example program because I couldn't really get one running, but they do have a lot of tutorials and built-in examples here. And you can see there's just a whole bunch of stuff you can do with this. Just like a whole bunch. Here's a card example. And I also included a screenshot of what it looks like when you're actually in a project that's working. So you can like graphically design the user interface, and they've got a whole bunch of different components, but you interface with them with code down here. And yeah. So now we're on to SDL. Oh, also I should mention that Qt, it runs on, I think it says that it runs on literally everything, like not even figuratively, not even the figurative definition of literal. Like if you click on deploy here, any operating system, any device, any screen, you can get it to run on a fridge. So if you're working with fridges, this is the option for you. Yeah, so SDL. It's kind of a game engine, but not. It does all the stuff that game engines do. It's less of a game engine than Love, but still more of a game engine than most things. Here they have examples of games that were made with SDL. Let's see. Yeah, I've got an example here. You can target a lot of different platforms with SDL. I think it's all the main desktop OSs, and then also mobile is what SDL works with. So this is what a basic program looks like in SDL. You initialize it, make the window. You got to specify all the different things of the window. Then you also make the renderer, and then a lot of the stuff that you do in regards to doing things is the renderer. Like, you do it to a renderer, and then the renderer has a window that it renders to. So, yeah. And so for this example, it just makes a green window that goes away after 3 seconds. There it is, and there it's gone. With this type of thing, I recommend using Visual Studio and following a tutorial, at least for the start of learning how to do it, because the different dependencies and stuff with the includes and the libraries, it can get a bit hard to manage, and Visual Studio lets you just kind of link it once and then forget about it. Same applies for when I talk about OpenGL later. But you can just do it all in a terminal. And, whoops. And this does all the like 2D, 3D, render a cube, render a sphere, all that type of stuff. Unity. It's very much a game engine, but it also is convenient so to use for other things. As I said earlier, if you're doing 3D and you want to do it fast, Unity's a good way to go. If you download it, it'll download the Unity hub, where you then have to download the version of Unity that you want. It's for keeping track of if you have multiple projects that are on different versions of Unity. Here's like a mostly blank project that I made earlier. Takes a little bit to load, but I won't spend too much time on this because it's fairly user-friendly and there are billions of tutorials for it. And so this is how like most game engines work, is you've got the scene here and then you've got the things that are in the scene in a list, and you've got, when you've selected one, there's all this stuff over here that tells you things about it. And then you can also have different assets in a different view. So then you can add the default things from here, which there's a bunch of different default things. Here's a cube. It's a small cube. No, it's just far away. And I can bring it to the origin by going over here and doing 0, 0, 0. Now I don't know where I am. Here it is. Yeah, so here's the cube. You can preview what it'll look like. You can run the game at any point. And then to do scripts, you do, in this over here, add a C# script. And then you can just open that with Visual Studio. Yeah, and it'll just open it as a Visual Studio project with a template that you can just start doing stuff with. And you can import things in a whole bunch of different file types. So like, I made something in Blender. Let's see. Import new asset. Here. Here's a statue of Rutherford B. Hayes that I imported into Blender and messed around with, and now it's still a Blender file, which isn't supported by all things, but Unity does support it because they support every file, basically. That's taking longer than I thought. Okay, yeah. And now here's a bunch of Rutherford B. Hayeses. Just drag and drop. And I think it froze. Too many Rutherford B. Hayeses. Just gonna close that. Okay. So any questions about the previous ones that I forgot to ask questions about? or ask 4 questions about, like love, Qt, SDL, or Unity. Alright, let's keep on going. We've got the big boys now. OpenGL / WebGL if you're on the web and want to do 3D. This gets pretty complicated, but it is doable. I've linked to some pretty good tutorial series here. If you want a text-based one, learnopengl.com is really good. It goes through a whole bunch of different stuff. Like from here to here, with pages of roughly this length, that all tells you how to make this. And then it also goes into more advanced topics like anti-aliasing and advanced lighting options like physically based rendering. So you can do pretty impressive stuff with this without having to dig too deep into the documentation. Let's see. There's also, if you prefer video, a YouTube channel called The Cherno made a pretty good series on it. I'd say they're pretty similar, given they're over the same thing at a basic level. So it's just a matter of preference. And then if you want to do WebGL, the Mozilla Web Docs are very good for anything. So if you're doing something that this covers, look at them because they're very good. And they've got a tutorial for WebGL. And then I have an example project for OpenGL just to kind of show how complicated it gets early on, at least. So currently this just prints out an image to the screen, but because it does it in 3D via OpenGL, there's a whole lot of stuff here that it has to do first. So basically what I'm saying is, if I wouldn't recommend using this for simple projects unless you already have like a good setup going for starting up projects quickly with OpenGL, because there is a lot of stuff you got to do before you can get into the meat and potatoes of what you really want to do. So if you run this, you can see it has a little pineapple here, and it loads in this image from a file via this library stb. Yeah. And OpenGL is another one of the things that works on like most platforms, I'd say. For mobile, you gotta use OpenGL ES for embedded systems, and then for web, obviously, WebGL. But with those three combined, basically everything other than Mac is supported. So any questions about that type of thing? I think I'm done with my slides, so I'm just gonna go back through and make sure I didn't miss anything important, at least. Yeah, I think that's all I really wanted to mention. I could have gone a lot more in depth into any one of these, but I wanted to make sure that I covered a lot of stuff so that you knew what you could use for various different like types of problems. And a lot of the same principles apply to all of these. So like if you want to start like graphics programming just to get good at graphics programming, then I'd recommend learning Love and then going to SDL and then OpenGL and WebGL. That's a track that I'd say would be good, because Love is super easy but also works in the same way that these do in a sense. And really you don't even need to, for most purposes, you don't ever really need to use OpenGL. It's just kind of a, if you really need the control that it provides. Now I'm just kind of rambling, so I'm gonna call it there and leave it on this image because it's a fun image. Thanks for watching the presentation and listening to it also.